Right. Hello, everybody. So I've been asked the question to clarify how to calculate the trigonometric ratios of the special angles. And when we are talking about special angles, essentially we are talking the ones on the table above, and that's going to be 0, 90, and then 30, 45, and 60. I will try to calculate first the 0, so I'm going to put number 1, and then number 2 is going to be 90 because these are the easiest ones. Then I'm going to show you how you can use a triangle to calculate the 45, and then number 4, both 30 and 60, because essentially we're using the same triangle to do those calculations. So let's go to calculate first the 0 degrees, and just to save a little bit more time, I've already drawn a unit circle, that means a circle with a radius of 1. And I've already written down the 0 degrees angle, which is this one here, and the x-axis, which is essentially the axis where we see the projection of each point, and that correlates to the cos of the angle, and then the y-axis, and then the 90 degrees, and then the y-axis, which is essentially the projections. They're going to be the sine theta. So what I mean by that, if we just choose an angle, let's put it theta 1, right? Then if I want to calculate the cos theta, I'm going to have to draw the vertical line, and then that's going to be the cos theta, right? That one here. And then if I want to calculate the sine theta, is going to be the projection on the y-axis, and that's going to be the sine theta. And this is where we are with that. So let's start by trying to calculate and see whether this is going to move the 0 degrees. So this is where I am with 0 degrees. And if you actually see what's happening, the projection on the x-axis, which is going to be the cos theta, is all of that length here, from here all the way here. And we know, because this is a unit circle, therefore the radius is equal to 1, that the cos theta, or this distance, is equal to 1. Therefore, the cos theta for 0 degrees, I'm here on the table, it's going to be equal to 1. Then we're going to move on to sine theta. And the sine theta is the projection on the y-axis. And because there's no angle at all, it's 0 angle, the projection on the y-axis essentially is just goes back into 0. Therefore, we have no projection along the y-axis, and therefore the sine 0 degrees is equal to 0. And then finally, if we want to calculate the tangent, I'm going to use the ratio. Now, to calculate the tangent of 0 degrees, I have essentially two options: to use the opposite over adjacent ratio when I have a triangle, which I don't have in my case, or to use sine theta over cos theta in case I know the values of the sine theta and the cos theta. And I do know, in my case here, therefore that's going to be the tangent of 0 degrees is going to be sine 0, which is 0, over cosine 0, which is 1. 0 over 1, that's going to give you equal to what? 0. And therefore, here we got it. We have a 0. Now I'm going to delete all of that, and I'm going to use the same kind of logic to show you the 90 degrees, how it works. So if you want to have a good look at it, then maybe you can pause the video and just try to see, work it out for yourselves, or maybe on a piece of paper or something. So here we are now on the 90 degrees, and I'm talking about this angle here. That's why the arrow has changed, or otherwise pi over 2 if you're talking about radian. And using the same kind of technique, we want to find the projections along the y-axis and along the x-axis. The projection along the y-axis is as long as the arrow, and we know that the arrow is going to be equal to 1, right? But at the same time, that represents the sine of the angle. Therefore, we know that sine 90 degrees is going to be equal to 1. Then we have the cosine, and if you see from that point here, their projection down just falls on 0, so we have no distance either side of 0. That means the cos theta is going to be equal to 0, the cos 90 degrees is going to be equal to 0. And then for the tangent, I'm going to do exactly the same thing like I did before. So the tan of 90 degrees, or the tan of pi over 2, and make sure you know both ways of writing 90 degrees in terms of radian and degrees. That's going to be equal to sine pi over 2 over cosine of pi over 2. The sine of pi over 2 is equal to 1. The cosine of pi over 2 is equal to 0. And here we have an issue. And the issue with this one is that we have a fraction over 0, and that means that it is undefined. Undefined. And that's what it is. Therefore, the tangent of 90 degrees does not really exist, it's undefined.